Hey everyone, and welcome back. Now today I wanted to talk about the holy grail of blockchain. Now some of you might be like, well, what is that? And others of you might already know what I'm alluding to, but today I want to talk about interoperability. Interoperability is kind of the thing that is the holy grail of crypto currently, right? Ethereum's trying to solve it. Polkadot was a huge one that was trying to solve it. Chainlink's trying to solve it. Everybody talks about it. Everybody's trying to, talk about, account abstraction, wallet abstraction, all this different types of stuff to essentially make the interactions between blockchain and various smart contracts and all that type of stuff kind of abstracted away into the background. So normal users don't actually need to really deal with it or be aware of how to use it or any of the consequences, implications, anything like that. And so one of the really important things that, this is something that has had multiple years of time, billions of dollars of money, and a whole bunch of really, really smart people's work on is interoperability. Now, something that's kind of interesting is I'm sure most of the people watching this video are ICP fans, so I'm kind of preaching to the choir on this. But I'm sure, as many of you are aware, ICP is kind of criminally overlooked, I would say, to an extent, just because they do a lot of really interesting work and have a lot of really interesting solutions to something that is currently a problem. And one thing that I'm seeing is like maybe this whole interoperability problem has actually already been fixed, and ICP is the one that has already fixed it. And so we're going to go into a little bit of that today and talk about why that might be and how and all this different types of stuff. But ultimately, before we get into that, I want to take a look at the chart just to kind of see where things are. And so what we can see here is, so I did actually adjust this top trend line. It used to be sitting kind of about like this. Now I'm not exactly sure which is the right way to view it, so I kind of moved it just to see. But if we see here, if we were to stick with this trend line, and I think this actually came up a little bit more like that. But if we were to stick with this trend line, we would see that it would have broken out and it come back, and it's actually like sitting on the upper trend line right now. However, if we were to adjust this a little bit like this, obviously we are kind of overlooking this, this high, this local high right here, but this does still fit within the larger wedge. So again, it's really hard to say. I don't exactly know if there's a right answer here or what that would be. I think this is kind of maybe two different ways to look at it. However, that aside, what we have been seeing lately is, I talked about this on the last ICP video that I did, but we hit the very top of this Bollinger Band, and usually when that happens, it's an indication that price typically is going to come back down to the middle, right? And so what we have seen is actually has come back down to the middle, and we're starting to settle here. So obviously this is looking pretty good from here. Where we go, it did kind of go below it and has wicked back up. So whether we continue down to the bottom side and maybe look for another bounce on either this trend line or this level of support, or maybe both, depending on how quickly we get there, this is something that I do still think is possible. Or maybe we see a bounce off of the middle of this Bollinger Band back up into this upper trend line. It's really hard to say at this point, but either is a possibility. And again, if we take a look at this second or this initial wedge that we drew, it could potentially be bouncing off both the upper trend line and the Bollinger Band median, off, and away we go, right? It's really hard to say. I don't know actually for sure what's going to happen here, but I think either is kind of like a valid take on what could happen. So anyway, I just wanted to focus on kind of the ICP chart where things are standing. Obviously, we did have this breakout, and this was due to the Bob meme token coming out. Overall, that massively increased the cycle burn rate on ICP and actually turned it deflationary for a little while. It has kind of come down a little bit since, but it was I would say a pretty good proof of concept for what could happen using the ICP network. So as you can see, I do basically all my trading on Margex, and I do almost all my charting on here as well, just so it does make it easier when I'm looking to get in or out of a trade. So if you are interested in trading as well, you can trade ICP up to 25x leverage, no KYC or VPN needed. They also are doing up to $10,000 of deposit bonuses and a $500,000 Caspa airdrop, which runs through the end of September if that's something that you're interested in as well. So if you are interested, check out my link below. As I say every single time, leverage trading is very risky. So, you do need to have a pretty good understanding of what leverage trading is, how it works. I might do a video on this later, just as kind of like a PSA. Whether you like to leverage trade or not, I do think it is interesting to know some of these things. But if this is something that you're looking to do, just make sure that you're being careful and responsible. So anyway, moving on, one of the things that I wanted to focus on is this is actually a Medium article, and it's actually written by Dominic Williams, who's the founder of ICP. And he basically is talking about the 10 reasons the internet computer will win. And this was actually sent to me by one of my followers. His name is Thorazine. Really, really nice, been super, super helpful about, directing me to a lot of really interesting ICP articles and sources of information to help me bring some of these, hopefully high quality videos that you guys are enjoying. That it's really important to me to try and demystify a lot of what's going on within ICP, just because I do think it is a super complex project. And so having the help of the community has been really, really helpful. So anyway, that was just I just want to give a shout out to my really nice and wonderful community members and followers, just because it does really, really help me. So I want to get back to this particular topic, which is basically, so this whole article, as you can tell, is quite extensive. I'm only mainly going to be focusing on this piece, just because, this would be a very, very long video if I were to go over everything. And so what I wanted to focus on in particular is the interoperability side of ICP. So looking here, we can see that ICP has like a chain key technology, which essentially allows its smart contracts to directly and trustlessly process the asset of traditional blockchains and interact with their smart contracts. This part is pending a later release, but this enables developers to use internet computer smart contracts as trustless multi-chain glue. Web3 services can use this technology to achieve full stack decentralization by replacing cloud functionality with internet computer smart contracts. Internet computer developers can develop DeFi 2.0 services and Bitcoin DeFi. So, this is something that's really, really quite interesting and obviously very revolutionary, because it does in fact solve the interoperability issue if this all essentially were to come to pass. And now we're going to go into the details of how exactly ICP does this. The Chainkey technology is actually pretty interesting and definitely like novel technology. So, that's something that I want to go into a little bit later on. What we can see here is that these third generation smart contracts, or basically what ICP calls canisters, they basically have access to APIs that allow their code to trustlessly and directly maintain accounts on traditional blockchains without the involvement of friction creating and insecure bridges, from which hackers have basically already stolen billions. And we know that the bridges are a very, very dangerous thing to have in crypto, because they're a massive target for hackers to hit. So we're going to go into canisters specifically, and then Chainkey crypto technology. So the Internet Computer website does have fairly extensive descriptions on both Chainkey technology as well as canisters, which we'll get into in a second. Chainkey is a little bit complex to explain and to go over. Obviously, you can see this whole thing is all about Chainkey, and they have options to kind of go deeper into each topic. So I kind of want to give a high level overview of what Chainkey technology is. If you guys have any sort of like further questions, feel free to drop them in the comment section below. Or if you want to go in and just go to Internet Computer's website, you could read about it further here as well. Also, if you are enjoying the content in this video, please do give me a like and subscribe. It really does help me out. I am trying to hit 10,000 subs by the end of the year. And so, if you'd be willing to help me do that, I would really appreciate it. So going into Chainkey cryptography, what we can see is there's kind of three core things of what it will do. But ultimately, what it will do is it allows anybody to verify the content received from Internet Computer, basically just by validating the signature, and they don't actually need to sync the entire blockchain. This is one thing that Ethereum is trying to deal with right now, and this is like a more lightweight version of how to like pull the data availability of previous stuff. And so, this is something that is definitely a bit of a complex issue, but ultimately with this Chainkey cryptography, you don't need to go through and have like the data availability be there. You can just basically count on the fact that it was done correctly based on the key. Now, the other thing is the topology of Internet Computer can evolve autonomously. Basically, new nodes and subnets can be added, faulty nodes can be recovered, and all this type of stuff. Basically, you don't need somebody managing this, but with Chainkey cryptography, it can kind of self-regulate in terms of what's actually needed within the system. Now, this is the other thing too, is, Chainkey cryptography allows basically a source of unpredictable and unbiasable pseudo-random numbers for canisters. Canisters can securely run algorithms that need randomness. So this essentially is kind of the core that allows canisters, at least from my understanding, it's the core that allows canisters to operate in the way that they do. Canisters, I guess you could kind of, you could convert them into being like mini bridges or like individualized bridges. I think would probably be the easiest kind of crypto mainstream way to put it, because what these canisters do is they have the ability to essentially reach into other chains. So if we go down here, and the way that they can do this is with their chain key signatures. And so this is something that essentially allows interchain operations because of these chain key signatures. So one thing that Internet Computer is already kind of focused into currently is Bitcoin. And so there's essentially they're able to use their canisters to create a Bitcoin integration. And so what were to happen is, like, let's say you're on ICP and you wanted to send Bitcoin from here to there or something, right? Like, what you could do is you could essentially use ICP to create a canister. Now the canister can actually generate a Bitcoin wallet in itself, and it can, buy this Bitcoin off of a centralized exchange. It could buy it off of a DEX, maybe on Bitcoin, or something like that. If bridging is needed, then maybe it could operate the bridge itself. But essentially what it does is, once it has that Bitcoin in its wallet, it can go and interact with smart contracts, it can do whatever it needs. And again, all of this is within a single localized canister. So it's able to operate and reach into Bitcoin without me actually needing to do anything within the Bitcoin system. But it's actually happening. It's just all been abstracted away thanks to the integrations and the APIs and all this type of stuff that ICP has enabled. So Bitcoin and Ethereum are kind of the two main ones that they're working on right now. But this is something that theoretically could apply to any chain. Now, an interesting result of this is these chain key tokens. And so one thing that ICP has already done is they've created Chainkey Bitcoin. And essentially it's a cryptography based replacement to like a bridged asset. So like, wrapped Ethereum, wrapped Bitcoin, all this type of stuff. Because essentially what it's doing is it's using these canisters to custody the Bitcoin. And you can now go use your CKBTC to do whatever, and people actually know that there is a canister somewhere that has this Bitcoin, and can essentially, the CKBTC can be used to claim that Bitcoin. So this is really interesting. It's really cool because it works almost exactly like wrapped, Bitcoin or Ethereum or whatever, but it's not sitting on this massive bridge or protocol that is susceptible to being hacked, because it's sat in these very small, almost essentially individualized canisters that people can spin up to do these individual actions that they're needing. So this is kind of, in a way, like, it kind of fixes the bridge problem, which is, again, one of the main issues with interoperability. And you don't even need to be the one to deal with it, because it's been abstracted away due to these API integrations within the Bitcoin and Ethereum ecosystem. The next thing I want to go over is canisters specifically, because I'm sure there's a lot of people who are like, I don't get this whole canister thing, right? It doesn't make a whole lot of sense, which is fair. Canisters essentially, if I had to boil it down into a TLDR, I would say that canisters are essentially autonomous, spin up and spin downable smart contracts, right? So if you have something like let's say you want to go bridge CKBTC or something like that, you can spin up a canister that will then interact within the Bitcoin ecosystem for you to obtain the BTC and do all this type of stuff. And then now you can go take your CKBTC and do whatever else. But this canister is essentially an individualized node that has the ability to custody and control this Bitcoin based on whoever controls this CKBTC, which again is secured by these chain key signatures. So it's got a lot of very advanced technology and cryptography behind it to keep it secure. So I'll essentially just kind of read this bit that ICP has regarding canisters. So essentially what they're saying is, smart contracts on the internet computer come in the form of canisters, computational units that bundle together code and state. Each canister defines functions that can be called by other canisters and parties external to the internet computer, such as browsers or mobile apps. Canisters communicate with one another via asynchronous messages, but the execution of each such message is done in complete isolation, allowing for massive levels of concurrent execution. Canisters are managed by controllers. The controller structure of canisters can either be centralized, e.g. when the controllers include some centralized entity, decentralized when the controller is a DAO, or even non-existent, in which case the canister is an immutable smart contract. Controllers are the only entities which can deploy the canister to the internet computer, start-stop canister execution, and update the canister code. The controllers also need to ensure that canisters hold sufficient cycles charged for processing, memory, storage, and network bandwidth resources consumed by the canisters. To this end, the IC monitors the resource usage of the canisters and deducts their consumption from a cycle balance maintained locally by each canister. So essentially, these are kind of self-contained, isolated smart contracts that allow for some of these more abstracted processes, right? Because ultimately what you can create is you can create this isolated bridge or, smart contract or DApp or whatever, however you want to look at it, that can do certain things regardless of the state or, the nature of whatever you're doing. So if you have CKBTC, as long as you have the chain key token associated with the CKBTC, this canister will remain there waiting for somebody to essentially redeem their CKBTC or spend it or do whatever they're going to do with it, interacting on the Bitcoin network or doing, whatever else. So, this revolution, I would say, is something that is super, super interesting and very unique to crypto, because this ultimately solves the crypto problem, right? I know that there's been a lot of development on Bitcoin lately. ICP could potentially help speed that along, because they have a lot of these innovations that could potentially rely on the Bitcoin layer 1, but use ICP as part of the infrastructure that helps build it. I think there's a lot of flexibility here. Same thing with Ethereum. Potentially, if people were to use ICP as their compute provider instead of AWS or whatever, you could essentially no longer fracture liquidity when you're moving between layer 2s on Ethereum. There's a lot of things that these canisters and this chain key technology can do to keep liquidity within the crypto ecosystem from getting fragmented. And so that's why I think that, it's very possible that ICP has in fact solved the holy grail of crypto, and people just don't realize it yet. And so that to me is something that's really, really interesting. One thing that I also wanted to mention too, something that a lot of the people in the ICP community bring up fairly consistently, and I feel like is actually very spot on, is the fact that nothing is guaranteed in life, right? I mean, ICP could go to zero tomorrow. That is entirely a possible outcome. However, usually when you're investing in very high growth things like this, you need to adopt more of a VC mindset. So what I mean by adopting the VC mindset is essentially what you're expecting is, let's say you invest in 20 different projects and you are fully intending on 19 of those 20 projects to go to zero. Obviously, I know that's not usually how it works. Maybe some you sell at 50% loss, maybe some you sell at a 3x, maybe some you sell at break even, whatever, right? But let's just, for this example, assume that you are expecting 19 of the 20 companies that you invest in to go to absolute zero. But if one of the 20 that you invested in goes 100x, as long as you invested in each of those 20 companies equally, you've 5x'd your portfolio. Right? That's kind of how that works generally, I would say. So that is something that I think is very important for people to think about and to realize, is that while nothing is guaranteed in life, when you're doing this type of investment, what you're looking for is a very, very high risk reward ratio. That's kind of I guess you could say the VC mindset in terms of how that type of stuff works. And this, I think, is something that's very prevalent within the ICP community, is they understand that this could in fact not work and go to zero and do all this type of stuff. But the risk reward is in fact high enough that it definitely is, it makes sense, and it warrants at least some level of investment within the ICP ecosystem. Obviously, this is not financial advice. This is completely my opinion. Obviously, the assessed percentages of success are completely subjective. There's no objective measure to come up with that. So, that's something you also need to remember when you're doing this, is this is not something that's a science purely, right? It's it's art as much as it is science. So hopefully what we went over today gives you at least a little bit of clarity both on how ICP works, as well as how interoperability could potentially look within the wider crypto ecosystem. That's kind of what I was going for today. So if you think I did a good job, please do give me a like and subscribe. It really does help me out. I am trying to reach 10,000 subscribers by the end of the year. I know it's a tall task, but I definitely, I'm up for the challenge, so I'm going to try and make that happen. Otherwise, if you have any comments, questions, feedback, anything like that, please do leave them in the comment section below. I really do enjoy reading and replying to all of my comments. I just find it interesting, the things that you guys have to say. And I also really appreciate any, suggestions and feedback and whatnot. So anyway, thank you for tuning in, and we'll see you in the next video.